do this one. Uh, what you have here is that a particle is traveling on the x-axis and has position x of t at time t. Now, the velocity of this particle is shown by this graph. Um, the key about this one is that you first need to realize is that it's asking for distance and not displacement. So we need to have a distinction between distance and displacement, right? So if I walk, if I get up, I walk to the printer, and then I walk back to my seat, my displacement is 0. But my distance is, let's say it's 10 feet to the printer, the distance that I've traveled will be 20 feet. Okay, so that's the difference between distance and displacement. Now, to do this one, okay, let's get a picture of what's happening along x of t as it is that we look at this curve here. So here's t, here's x of t. And basically, if you see that we don't know where the particle starts off, so it could start off right maybe here. Okay, it could start off with some initial displacement. Okay, so it's position, displacement. Its initial position could be here, and basically the velocity starts off as being positive. So then that means that as time goes on, the position of the particle will go up, 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 up until the velocity turns to being 0 at some point. Now, when it turns to being 0, it then begins to go down. Now, let's say that this is 5 seconds right here, and where it's 0 is 3 seconds. Using this rough sketch, it's going to make it a lot easier for us to answer the question as to which expressions gives us the total distance. Now, remember, if it's the case, right, the particle, this is it moving along like a straight line. It's moving along the x-axis. It's moving along here, right? So you want to find out how far it's gone to 3, and then at 3 we need to realize that the particle then turns around. But I don't care about the displacement. I care about the distance. So I care about the distance that it went to get to at 3 seconds, and then I care about the distance that it traveled in the other direction from 3 to 5 seconds. So which one is going to do that? Well, so first I want to compute this distance. I want to compute the difference between this height here, because that's the distance going to the right, and then I want to compute the distance going to the left. So the distance going to the right is whatever this value is right here. So this value is x of 3. Right? This value up here is x of 3. And then this value down here is x of 0. So that means that this distance is just x of 3 minus x of 0. Now, that's the distance that it traveled going to the right. You now need to compute the distance that it traveled going to the left, going backward in the other direction. And if you look, this is going to be, right, this is x of 3. This is higher than x of 5. Okay? So since it's the case that x of 3 is higher than x of 5, right, I want to compute this distance that it went. That's x of 3 minus x of 5. Okay? And your choice will be C. Okay, which is exactly this expression here.